Hello and welcome to Live Code Stream, where we not only talk about programming, data science, and artificial intelligence, but we also code. I'm your host Juan, and today we're gonna talk about smart contracts, how to build them, how to deploy them, and how to interact with them through web applications. So let's get started. Alright, let's now jump into my screen and start programming. So for creating this particular project, we are going to need two things. First of all, we're going to need a smart contract, and then we're going to need a website that connects to that smart contract. So we're going to start by creating the smart contract. It's going to be very, very simple, just for showcasing purposes. So I'm right now on the Remix IDE. If you don't know what Remix IDE is, I recommend that you watch my previous video on how to deploy an ERC20 token. I'm gonna leave the link to the video in the description. And yeah, so let's create a new file. Remember, the name of the file can be anything that you want. So in my case, it's gonna be my smart contract.sol. And then I'm gonna head to the compile tab here just to check what is the current version of the compiler. We have 066, so I'm gonna specify that at the beginning of the file so that the compiler knows. So this is actually Solidity, and this is gonna be working for any version, which is 066 plus. And then I'm gonna create a contract called the cool number contract. It's gonna be very simple, very simple to get us started. So we're gonna start by creating an unsigned integer here. We're gonna make the unsigned integer also public. So that means that this variable will automatically have a setter created for us. We don't need to do that. And then we're gonna create a setter function called the set cool number, and it's gonna expect an unsigned integer cool number here, and this is gonna be public. So we can also call it from our web application, and we can say that cool number is equal to cool number and semicolon. So what this smart contract is doing is very easy. It's going to store a variable called cool number into the blockchain with an initial value of 10, and it's going to have two functions. One function is the cool number getter and the set cool number, which is a setter. So in here we can change the value of the cool number, and with the getter function that is automatically created because this is a public variable, we will be able to retrieve that value. So let's compile now my smart contract. And if everything is fine, you should see a screen like this. Excellent. So the next thing we need to do is to actually test that this works. So we're gonna head into the module deploy and run transactions within Remix. And once we are there, we'll make sure for testing purposes that we have here selected the JavaScript virtual machine. And let's then hit deploy. So once I hit deploy, I get my contract deploy here, and I can expand, and I can see my two methods, the set cool number method, which is the one we define, and the cool number variable method, because we made this public. So now if I click on the cool number method, I get that the value is 10. And if I call the set cool number method, for example, with the number 40, and now I can click on get cool number, and now the value is 40. Pretty simple, right? Okay, so this is working. So now that we know that this is working, we can move and change the JavaScript virtual machine from the environment to the injected Web3 so that we can deploy our contract using MetaMask. If you have your own instance of Ethereum network running, you can also use a Web3 provider. The steps are going to be the same after that, but you will need to provide the address where you're running your network. So in our case, we're going to just use MetaMask in the Ropsten network for our testings. All right, so now let's deploy this contract. So when we do the deployment, MetaMask will ask us for a verification. So as you can see here, we have some gas fee that we need to consider. Of course, because we are in Ropsten, I don't mind so much about that. So I'm simply going to accept the gas fee and move on with it. So deploying the smart contract can take a few minutes. In this case, has actually been very fast, and we can see here our contract already deployed. Yeah, cool. In here we also have the transaction that created the smart contract in Etherscan. This is gonna be important because we are gonna need this too. We are gonna need this contract address when we create our web application. But let's go ahead and do that. Yeah, let's go ahead and jump into my Visual Studio Code, where I already have something here created for you. It's just a very basic skeleton. The only thing that I'm doing here is create an HTML structure, setting up a title, and loading a script, which is the Web3 script from my node modules. This is you can simply do npm install web3 and it will add this library for you. You can also use a CDN. The important thing is that you have access to this library from within your code, otherwise it's not gonna work. And yeah, so make sure you have the library, and once you did, let's start programming. So we're gonna create first of all some body, and in our body we're gonna have a simple website layout. Let's put a title here, Web3 demo. We're gonna put a break line, then we're gonna have two buttons. Our first button will be a print cool number. We call a function called the print cool number, and this is actually gonna be the print cool number button. And we're gonna have the same thing, so I'm gonna simply copy and paste, and here we're gonna have change cool number, and the same thing here, change cool number. All right, here we go. So then we're gonna have two breaklines, and we're gonna have a status field where we're gonna print simply what we are doing, right? So let's use a span for this, called status, and initially it's gonna be loading, right? So that is the first message that we wanna display until we know things are working. So let's see now how that works. So I'm gonna save that. I'm gonna go into my browser, and I have that open here in localhost. I'm already running a web server, so make sure you do that. You can also load it from your file. That's also all right. So now if I load the screen, we can see here print cool number and change cool number. But of course they are not yet doing anything because we didn't create the functions. It's a simple click here. The functions are not defined. So let's go ahead and start working a little bit on the functions. So we're gonna create a script tag now of the type JavaScript. There we go. And inside here, we need to do a few things. The first thing we need to do is we need to load the Web3 component. And for doing that, we're also gonna depend here on MetaMask. So I'm gonna do async function load Web3. Why is it async? Because I wanna use await inside. If you don't know what that is, I'm gonna leave also a link in the description of the video with an async await explanation so that you understand what is happening here. And now I'm gonna do if window.ethereum, and remember, if you're using MetaMask, this is gonna be automatically injected. And then we're gonna do window.web3. We simply wanna capture our instance of Web3, and we're gonna say it's a new Web3 of window.ethereum. If you're using your own network, instead of using window.ethereum here, you are gonna need to pass the instance of your own Ethereum network. And next we're gonna do window.ethereum.enable. All right, cool. So this will simply load our network and give us access to it, but we still need to call this function. So let's actually call, let's create an async function called load for all the things that we need to load. We're gonna see we need a few things more. Then we're gonna await for load Web3, right? And we are also gonna have, and then we're gonna call this function load. I forgot to close the brackets for the load Web3 function. So let's make sure you do that. And of course I did everything wrong. So now we have a load web3 function. We have a load function which calls the load web3 function, and then we are calling the load function here just to make sure everything is loaded. I think that's fine. Let's go back here and let's refresh the page. And when we do so, MetaMask is prompting here and it's asking for our website to connect to MetaMask. So we're gonna select one of the accounts. In this case, I'm gonna select my account here that has some Ethereum that we can use, and click on next. I authorize, of course. I trust this developer. And now we are connected, though our status still says loading. So let's go ahead and fix that. So let's create here an update status function, and we're gonna say we are ready. And of course we need to define our function update status, and it's gonna expect as a parameter the status we wanna send, and we're gonna simply change our span that we had. So we're gonna call this status element equal document dot get element by ID, and our span name, which was status, and then status element dot inner HTML. I'm not sure if we really need HTML here or text will be enough, but let's do that for now. And we are also gonna console log what we are doing, so we have a history, right? Because in the span element we always show the latest status, but we're gonna have everything in the console. So let's now go back into our Web3 demo and we click refresh, and now the status is ready. Great. We have a typo here in console. We refresh again and now it's fine, and we have the status ready. Cool. So we are connected already to MetaMask and thus to the Ethereum network, but we need to connect to our contract, right? So how do we actually connect to our contract? So what we are gonna do is, after we load Web3, we're gonna do window.contract. We're gonna save the contract on a global instance so we can access it from other functions, and we're gonna do load contract. All these functions require the await, because I really want to wait until the contract is loaded, until I show the status to ready. I don't want this to happen on a separate thread or asynchronously. I want to make sure the execution here awaits for the results. So all right, so now we need to declare our function load contract, and this function is going to be a little bit complicated compared to the rest, and let's see what I mean by that. So we have our function called load contract as we define, and then we're going to simply return await. So we're going to return the contract, right? So to get an instance of the contract, we need to call the Web3 instance that we have on our global window instance .ethereum or ETH .contract. And the method contract expects two parameters. The first parameter is called the bin of the contract, which we can get from the Solidity compiler here in the ABI section. So the first parameter is the ABI, sorry, I pronounced that wrong. So the first spell is called the ABI, ABI. And we can simply copy here from the compile section. After you compile your code, you can copy that, and that's going to be the first parameter of our contract. And it's simply an array. It could look a little bit scary, but it's not. Actually, it simply defines what are the inputs and the functions and the types and everything in an array format. It's pretty actually convenient to work with. And the second parameter that it expects is the contract address. And the contract address, we can either copy it from the deployment section that we have here. So if I move this all the way, I can copy the contract address here, or we can also get it from the two section here on the address, so they are the same value. And that's what we are gonna add here as the second parameter of the contract function. So this will return an instance of an object that we can actually use to interact with the contract. Now calling functions within the contract is not going to be a straightforward as simple dot function name and then opening brackets, but it's going to be pretty simple. So yeah, so let's see if that let's see if this still works. So now if I'm on Web3 and I refresh my page and I wait, oh, so we got a new error here. Please use the new keyword to initiate a Web3 contract object. So yeah, so we forgot the new keyword here because the contract is actually a class and we need an instance of that class. We need to use the new keyword. And now if we do that, we are ready. So that means if right now I do window.contract, and there we go, we have an instance of our contract with all the properties and functions. Great. So now that we did that, the only thing we have pending to do is actually to build our functions to print the cool number and to change the value of the cool number. So let's go ahead and do that. I'm gonna create a new function. This is gonna be the asynchronous function again, called the print cool number. It's not gonna expect any parameters, and we're gonna update the status. And first we're gonna say fetching cool number. So that means we are loading the number, and then we are gonna load the number into a variable, which is our cool number variable. And we're gonna await, and we're gonna wait for window.contract. Remember, we wanna interact with the contract we already loaded. And then we are gonna do .methods, because we wanna call a method within this contract, and the method name as a function, exactly. And lastly, call will simply say, call this method from this contract, and that will actually execute the remote call. And after we are done with that, we are gonna print the result. So we are gonna say our cool number is cool number. So this is called a string literal in JavaScript. It's a mixture between text and variables. We can encapsulate the variables between the brackets and the $sign, and then it's gonna be replaced by the actual variable there. So cool. Let's see now that in our browser. I'm gonna refresh the screen, and then I'm gonna hit print cool number, fetching, and the cool number is 10, which is our default value. Excellent. So this is now working. I can print it again. We get exactly the same thing. Amazing. So now let's do the change cool number. So it's actually pretty simple, right? Once you get used to this weird way to call functions, it's pretty simple. So change cool number expects no parameters because we are gonna generate our value automatically. So remember, we are using unsigned ints. So it is very important that you don't send any negative values and that you don't send any floating points. So we're gonna use the mat.floor function to make sure we get a round number, and then we're gonna generate a random number from 0 to, let's say, 100. And we're gonna call the update status here, and we're gonna say updating cool number with value. So we are changing it for that number because otherwise we wouldn't know. We are generating it randomly. And then we're gonna need const cool number, and we're gonna do something similar as to before. So we need window.contract.methods.set cool number, and then we're gonna capture the value. So we're gonna send the value, and then you will think here that we actually need to do a call, right? So that we need to do something like this, but this will be wrong because since the set cool number is a setter, we need to actually use another function, and the function is called the send. It's called the send function, and the send function will expect an object with some send parameters. And the reason why we need to use the send is because this particular function that's gonna alter something in the blockchain requires a transaction. Remember, every time you wanna change something in the blockchain, you need a transaction, and that transaction needs to be inside a block, and that block needs to be mined. So that's how blockchain works. That's how we get everything consistent in the blockchain. And the only way to send a transaction is if you have an account. So when you send something that's going to alter something in the blockchain, you also need an account you're going to be used to send the data from, right? But we don't have any account, so how do we know which account we want to use? Well, we can simply declare a variable called the account, and we could always go to MetaMask, and we can copy our account number from there. We can paste it in here, and then everything should be fine, right? So let's try and see how that works. Let's try to see this works, okay? So I'm gonna refresh the screen. I'm gonna click on change cool number. So MetaMask now is popping up and it's saying me from the account 1, I'm gonna create a transaction. This is the contract transaction. This is gonna be the gas fee for this transaction. Remember, we are simply changing a number here from 10 to 63, and we need to pay gas fee. So every single transaction that you do is gonna come with a gas cost. So keep that in mind. So I'm now gonna confirm. This is Robston network, so we're good. And now when I confirm, so we got here the updating cool number with 63, and eventually we should get a response saying that this got updated. Oh, sorry, we didn't actually created that update status, so it's gonna hang in there. But now if we go to print cool number, actually here the transaction just got confirmed. I got a notification. If now I click on print cool number, the number we are fetching is 63, so it actually changed. So it's quite interesting, right? So let's do the following here. Let's do update status, and then here I'm gonna say updated, right? But things starts getting awkward now, because if I'm using MetaMask to interact with my application and I already authorized my account, why do I need to provide again my account number? And you're right, this is not entirely necessary. We can get the account numbers from MetaMask, and that's what we're actually gonna do now. So let's do await get current account. It's not actually gonna be the current account, but it's gonna be the account we wanna use. Let's create that function. Get current account, and what get current account is gonna do is simply, sorry about that, it's simply gonna create, it's gonna get from MetaMask all the accounts on MetaMask. So this is window.web3.eth.getAccounts. So that's gonna return an array of accounts, and we are gonna do this. We're not gonna sanitize anything. We're gonna simply get the first account, and we're gonna pass that account into the send function. So now if we go back to our web browser, now we can click on change cool number. It's updated now with the number 38. It automatically got the account, so we don't need to hard code the account number here, and we can click on confirm. And eventually this is gonna change to updated when the transaction gets completed. All right, there we go. Well, we got our pop-up notification and also our status change to updated. Pretty cool. And we can print the number, and we see now it's 38. It's not anymore 10, nor 63, now it's 38. All right, that's all I wanted to show you for today. Today you learned how to build smart contracts and deploy them. Also how to build web applications that interact with those smart contracts by receiving data, and by also creating transactions inside the blockchain for those smart contracts. I really hope that you enjoyed the video, and if you did, please make sure to smash the like button. Also subscribe to my channel. I'm gonna be continuously uploading new videos related to programming and also to blockchain. And see you the next time. Thanks for watching.